Okay, 7th graders, we finished up your circles and cylinder unit. So you guys can return those packets to me if you haven't already done so. You can do this by, like I said on the Google Classroom page, you can do this by sending them back with those people that deliver other homework packets or your lunch, or you guys can drop them off at school. Just make sure that my name and your full name is on them. I think that packet actually had my name on it, but make sure your name is, and this one doesn't, so you might want to put my name on there. Anyways, there's no huge rush. Just get them back to me within the next week or so and have them completed. I will be flexible with that. But what we're going to pick up on today is chapter 5. Now, if you remember, we started this chapter before we started circles. So we actually did the first 3 sections of it, and I did include those, and you guys probably have them in your math notebook, but if you don't, I put them in here. So the first one, we just talked about the coordinate plane. This seemed to be review for you guys, how to graph points. Then the second one was reading a graph, you know, if something stays constant, if it decreases, if it increases, what does that look like on a graph? Those types of things. What kind of words that can you pick out? So those were those assignments. And then the most recent one was when we would be given a function and we have an input and an output, and we put inputs in to get our outputs, which produced ordered pairs. With those ordered pairs, you could graph them. So we did a few different examples. We did one that produced a straight line. This one produced a parabola, this is called. So those are different types of functions produced by an equation. So today we're actually going to skip section 5.4, and we are going to jump right into 5.5. Now 5.5 is very similar to 5.3. We are going to be graphing using the same methods, but these are all going to be linear. The big thing with linear is that they are going to all produce a straight line. So if for some reason you are graphing and it doesn't produce a nice straight line, then you probably did something wrong, okay? So you just can check your operations again. So my notes today are going to be really short. You guys have a couple pages of homework to complete after that, which is really good practice here. So I didn't give a ton of room. We've got 2 graphs and 2 equations. I'm going to make a table for each one, just a really simple table. Maybe I'll just do it up here. We have an input, we have our function, and we have our output. So for your points that you're going to put in, I always suggest doing -2 to +2. You know, it's 5 points, but this doesn't really take us long. So this is going to be 2 times -2 plus 1. 2 times -2 is -4. -4 plus 1 is -3. 2 times -1, you guys can go ahead and use a calculator to do these, that's fine. 2 times -1 is -2. -2 plus 1 is -1. 2 times 0 plus 1. 2 times 0, 0 plus 1 is 1. 2 times 1 is 2, plus 1 is 3. And 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. So you are going to go to your graph now, and these are your xy's. -2, -3. So -2, -3. -1, -1, 0, 1, 1, +3, and 2, +5. 1, 2, 3, 4, 5. So there we have our points. Notice that they form a nice straight line. So that means that I must have done my math correctly. Okay. So your next one Again, I'm sorry for not giving you guys much room on your worksheets. There's a lot more room for these. Okay, so again, -2, -1, 0, 1, 2. So this is going to be 4 times -2 minus 1. 4 times -2 is -8. -8 minus 1 goes down further is -9. 4 times -1 minus 1. 4 times -1 is -4 minus, oh sorry, it's shadowed. -4 minus 1 is -5. 4 times 0 minus 1, this is 0 minus 1 is -1. 4 times 1 is 4, minus 1 is 3. The last one, 4 times 2 minus 1, this is 8 minus 1 is 5. Then we can go to our graph. -2 and -9 is all the way down here. -1, 1, 2, 3, 4, 5, 0, -1, 1, 3, and 2, 5. 1, 2, 3, 4, 5. Ooh, that one doesn't seem right. Oh, it's 8 minus 1. Sorry. See how I checked that? So it's 2 and 7. 5, 6, 7. So I almost plotted it right here. Can you guys see that? And sorry, it's hard to see with that shadow. And I knew that wasn't right. So I double checked my math and I made an error. Like I said, you guys, these are going to produce a straight line. So if it doesn't, it's a big red flag. Okay. So the other types of problems you guys are going to have are word problems. The only thing that makes these tricky is if they don't give you an equation, you have to come up with the equation. And so it says, this problem reads, for every degree that a temperature increases on the Celsius scale, the temperature increases by 1.8 degrees on the Fahrenheit scale. When the temperature is 0 degrees Celsius, it is 32 degrees Fahrenheit. Write a linear function that describes the relationship between Celsius and Fahrenheit scales. Then make a graph to show the relationship. Okay, that's kind of a lot. I'm going to help you with this one. The equation basically shows us that it's going to go up 1.8 degrees for every degree. So you would take that 1.8 times every degree, and our starting point on the Fahrenheit scale is 32. Okay, so when we have 1 degree Celsius, you'd put a 1 in for the x, and 1 times 1.8 is 1.8 plus 32. Okay, so we have our equation. Now what you do is you think about your input values. So for example, you don't need, we could put in negative values, but we don't need to. So let's just pick out some nice numbers. So for example, we can pick out 0. Let's do maybe 5, 10, and 15, just to give us some numbers. So then we're going to go and we're going to put these into our equation. Y equals 1.8 times 0 plus 32. Y equals 1.8 times 5 plus 32. Y equals 1.8 times 10 plus 32. Y equals 1.8 times 15 plus 32. And this is where I would just do the calculations on a calculator. Obviously we know times 0, this would just be 32. 1.8 times 5 is 9 plus 32 is 41. 1.8 times 10 is 18. 18 plus 32 is 50. And then 1.8 times 15 is 27 plus 32. So this really only brings us up to 59. Maybe I'll just do, that's fine. Okay, so then the next part is to graph. Since we're only dealing with positive numbers at this point, I'm just going to do the first quadrant on our graph. Now I went up by 5s on my x, but my y's aren't as even. So as long as I can go up to 60, that's the biggest thing. So I'm just going to go up by 5s on my x. 5, 10, 15, 20. And then to go up by 60s, I'm going to go by 10s, and we're just going to estimate. So 10, 20, 30, 40, 50, 60. 20, 40, 60. So we're just estimating to kind of show the relationship. So the first one is 0 and 32. So if this is 20, 32 is just above, not a ton. 5 and 41. So just a little bit above 40. 10 and 50. So that would be right there. And 15 and 60. So you guys can see, I mean, this is just a sketch of the graph, but you guys can see this is actually has a pretty straight line. And the reason this is because there was a constant. There was a constant 1.8 degree increase for every degree Celsius. Okay. The next one, oh, and you probably do want to label these axes too. So this would be degrees Fahrenheit, and this would be degrees Celsius. Okay, the next one. The fastest moving tectonic plates on Earth move apart at a rate of 15 centimeters per year. Science, so this is a rate, okay? Scientists began studying two parts of these plates when they were already 30 centimeters apart. So that's kind of like your starting number. Write a linear function that describes the movements of these plates over time. So we have an equation. They move at 15 centimeters per year, and they are already 30 centimeters apart. Okay, so we started at 30. We add on 15 centimeters per year. So if there was 2 years, they'd move another 30 centimeters. So then I can just use this to make my table. Are we going to have negative years? No. So then your input is not going to be a negative number. So we could pick some numbers that might be kind of nice to multiply. You're just trying to produce that graph so you can show the relationship. So we could do 0, 2, 4, 6, 8. Okay. So then this is going to be y equals 15 times 0 plus 30. Y equals 15 times 2 plus 30. Y equals 15 times 4 plus 30. Y equals 15 times 6 plus 30. Y equals 15 times 8 plus 30. Okay, and then we can just do the math here. So 15 times 0 is just 0. So this would be 30. 15 times 2 is 30, so this turns out to be 60. 15 times 4 is 60, plus 30 is 90. 15 times 6 is 90, plus 30 is 120. 15 times 8 is 120, plus 30, so it'd be 150. So you can see that this went up by 30 every single time. So if we're going to make a graph, again, they are all positives. So this would be the number of years, and this would be the movement of the plates. And that's in centimeters. Okay, so I'm going to go just 0 to 8 on my axis here. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And the more even your numbers are, the more accurate your graph will be. And then you can see that I have to go up to 150. So I might want to go up by 30s even. So if I did 30, 60, 90, 120, 150, then I could graph my points. So 0 and 30, 2 and 60, 4 and 90. Sorry, I'm sure that's shadowing there. 6 and 120, and 8 and 150. And you guys can see what happens with that line. It's a nice increase there. And then you could use the graph to make other predictions if you needed to. So if you guys turn the page, you'll see your homework or your practice. Notice how I gave you nice tables to fill in and graphs. Even though this is 2 pages, if you really look at it, it's only 7 problems, okay? Not a big deal. And then I have an IXL strand out there for you to work on as well. So make sure if you guys get stuck on anything, you let me know. Use a calculator if you're having trouble with any of these equations. Remember to follow order of operations. But other than that, I think you guys are good. Hope that you're doing well, and we will talk to you Friday.